Okay, so our next little subsection, I'm going to actually rewrite our general form that we had for our radical expression. And you're probably asking me, well, why the heck did we need to know, like, what this was? Like, what does the rational power have anything to do with this? Okay. And initially I'd be like, yeah, that doesn't make any sense. Like, there's no check mark over on this side, so how are these two things related? Well, actually, we can actually translate between the two things. Okay? So that's literally the whole goal of this first section is translating between these two, knowing how to do that, simplifying stuff if we can, and then knowing how to use a calculator to type these in. Okay? Because initially what might happen is you might see this, okay, and be like, well, I might know how to figure that out, but I want to type in my calculator and figure out how to do that. Well, some calculators don't have an option to type it like this. You do have a square root option that's readily available, but sometimes calculators don't have the option. We want to make sure that we can change this cubed root of 64 into this form right here somehow. So that way we can actually type it into our calculator and use it. Okay, so that's the basic idea of this whole little subsection here. So I'm going to get rid of these little things, but I'm going to keep our... Actually, I should have kept the other one up there, but that's fine. I'm going to keep our general stuff. I'm going to put P over Q for this. That's fine. So how do we translate between these two? Well, there's like a little easy format to follow. Okay, if I'm given a radical expression that's of the form like this, okay, I see that the power on A is 1. You can probably agree with me on that. On a good day, a power of just a variable is just 1 if it's not explicitly stated. Okay, I can change this into A is still inside, but I'm going to put parentheses instead of a radical now. I'm going to take the power of A, which in this case is 1, and put it on the top. Okay. I'm going to divide then by the index. Okay, so the way I translate any general nth root of an expression that doesn't have a power, I literally just put the radicand, see A is the radicand that goes inside the parenthesis, and I raise it to the power of A, which is 1, divided by the index of my radical. That is basically what the section is. Okay, just taking a radical expression, translating it into its rational power form. And so if we were to get an example, I'm going to erase these. If I were to give you an example of something like translate the following radical expression, it's like the fourth root of x into its rational power form. How would you do it? Well, I'm going to put my parentheses down. I'm going to take my radicand and throw it in the inside. And now I raise it to the power that's on x, which is 1, divided by the index. Seems simple enough so far? I think the more complicated stuff gets involved where if I have something like the cubed root of x squared. Okay, the difference between these two is that I have a squared on this one and there was a 1 on this one. So how do I compensate for that? Well, basically, instead of having a 1 on the numerator, you are going to have a 2 on the numerator. Okay, so in general, when you have A to the P over Q, P is the rad, I'm going to put the rad power. Okay, it's the cool power. So the rad power is the power on the radicand. In this case, it's 2 here, it's 1 here. And then Q is the index. Okay, rad is on top, rad's cooler, rad gets the spotlight, he's on top. Q is the index, he's not so cool, he gets on the denominator of the fraction. That's how we kind of translate between the two. So that is an example of a radical expression into a rational power expression. We are also going to need to go the other way around. Okay, so I'm going to keep that over there. But instead now, let's say I give you an expression that's like x to the 1/3. Okay, how would I go to a radical expression? Well, I said that the rad part of the rational power part is the numerator. So I know that if I'm taking x and raising it to that, that's going to go inside right here. What is my power on x? Well, my power is the rad part. Okay, so the rad part is 1. Okay, and my index is found in my denominator of my fraction, so the 3 goes right there. So it's just knowing how to translate between the two. Okay, this is a comparison. What does x to the 3rd look like compared to x to the 1/3? Well, this is actually very weird looking, but this is literally like, this doesn't even make sense really either, but like this isn't something you would ever write down, but this is like the equivalent of what that looks like. Okay, you're taking the first root of x to the 3rd, which is just the same thing as x to the 3rd. So I think the easy way for me to kind of distinguish between these two is the first one only makes sense if you have like a 1/3 power. So if I have a 1/3 power on the x, it doesn't make sense to put the 3 right here and the 1 right here. Like that doesn't make any sense. So I think if you're given something that has a 1 on the numerator, the only one that makes sense is to do the top one here. Because the other way around, like this is like gibberish. So, but that is how you, that's an example of a rational power to a radical power expression. I'm gonna do another one. So another example I could give you, a little more complicated one. Let's do something like x to the -1/2. Okay, so I know that the inside of my radicand is going to be x. Okay, I need to figure out x's power, and I need to figure out what number goes on the outside of the check mark. X's power is going to be 1, okay? And I'm going to explain why I don't put the negative there in a second. The number that's on the outside of the square root, or the radical, I should say, is going to be a 2. In this case, since it's 2, we can just imply that it's there, because the square root's 2 normally. Okay? And that negative, I'm actually going to need to keep on the outside still. So this is the same thing as 1 over square root of x to the 1st. Okay? And then whenever you have a first power, you can just imply that it's there and just put it as x. So we may have seen this before with negative exponents. If we haven't, we'll cover it more in the next section for sure. But whenever you have a negative exponent, that makes your expression flip to the numerator or the denominator. Like I said, we'll see that more later, but that's just a little intro into that. So I won't give you any negative powers for this section, but it's just looking forward to see what might be coming up. One more switching from rational power form to radical form. If I were to give you something like the 16th root of pi over 2 squared. Okay, you're like, what the heck is that? Well, this isn't anything different than what we've seen, right? I'm going to put this into radical form. So let me put my check mark down. I'm going to copy what's inside there. Or wait, I'm sorry. We're going the other way. So I'm going to put my parentheses down. I'm going to copy what's inside, which is pi over 2. My numerator of my fraction is going to be the power that's on the radicand, right? The rad's power is the numerator. It's on top. So that's 2. And the bottom is going to be 16. And whenever you have something like this, we will need to simplify it down a little further. So pi over 2, if I take 2 over 16, I can factor out a 2 and divide it out. So that's the same thing as 1/8. So that is technically the simplest form of that expression, is pi over 2 to the 1/8 power. So that's a more complicated example, but that is how you would translate between the radical expression to the rational power function, or rational power expression, I should say.